Hi students, this is Satish Kumar and today I'm presenting the 10th video lecture on microwave waveguides. In the last lecture, we have seen the transverse electric mode of propagation. We have calculated the expression for the Hz, which is in terms of cos, okay, that is some constant c into cos of m pi by a into x into cos of n pi by b into y into e power j omega t into e power minus gamma z. This is the expression for Hz that we got. Now, by using that expression, we are going to find out the field components of transverse electric mode of analysis. So why we require this field components? Okay, in these field components, as it is mentioned, we are going to find out the expression for Ex, Ey, Hx and Hy. As we already know that Ez is 0 and also we have calculated Hz, so that means we need to find out, as we already know Hz, we need to find out Ex, Ey, Hx and Hy. But how do we find out? How do you find out these Ex, Ey, Hx, Hy? We have already calculated these field components in terms of Ez and Hz, as we already know that for the transverse electric mode of analysis, Ez is 0. Simply we need to substitute that Ez equal to 0 and we have to put the expression for Hz. But why we use this is because once we calculate the cutoff frequency, we can able to find which mode of transverse electric analysis will be existing. Okay, so generally the TE mode will be represented as TEMN. So the starting mode will be m equal to 0 and n equal to 0. So that is TE00. So that is a starting mode. Whether that mode will exist or not, we have to check by finding out all these components. If any, at least one component of these five is existing, that is non-zero, then we can say that particular mode is existing. Otherwise, that mode will not exist in TE mode of analysis. Now, as we have already calculated that Hz, which is purely in terms of cos, okay, as already seen, cos, or we can say cos of m pi by a into x into cos of n pi by b into y. These are the e power j omega t into e power minus gamma z can be represented as e power j omega t minus gamma z, and c is just a constant there. Now, by using this Hz, we will try to find out Ex first. Okay, so in the field component analysis, we have expressed this Ex as minus gamma by h square into dou Ez by dou x minus j omega mu naught by h square dou Hz by dou y. But for the transverse electric mode of analysis, this Ez will be 0. So this entire expression will become 0, and what is left is only minus j omega mu naught by h square into dou hz by dou y. Okay, because Ez is 0, only this will be remained. So what I will now do is I will substitute this hz, which is at the place of this. Okay, so with respect to y, we have to differentiate that hz. So minus j omega mu naught by h square into c is just a constant, because here we are differentiating with respect to y, and this cos of m pi by a into x is also constant. The c is a constant and cos of m pi by a into x is a constant, and only you have to differentiate this cos of n pi by b into y. So what you will be getting is minus sign, so that minus into here minus is becoming plus here. There is no symbol, means it is plus, and that cos will become sine, so cos of n pi by b into y will become minus sine of n pi by b into y, and again if you differentiate that n pi by b into y with respect to y, you will get simply n pi by b, and that I have written here. And finally this e power j omega t into minus gamma z is independent of y, so you can write it as it is. So now this is your expression for Ex. So once we get Ex, we need to go to Ey. Okay, Ey expression is almost similar to that, that is minus gamma by h square dou Ez. Instead of hz in the previous case, here we are writing it as Ez, so dou Ez by dou y plus here, that is j omega mu naught by h square into dou hz by dou x it is. So again, as it is transverse electric mode of analysis, here now the first term is going to become 0 here. Okay, the first term is going to become 0. So what you will be getting is again j omega mu naught by h square dou hz by dou x. Now here it is with respect to x. Now it is with respect to x. Okay, so j omega minus j omega mu naught by h square, you have to write it as it is. So that is the minus is not there here. Okay, so but as you differentiate that with respect to x, that cos, you will be getting this minus here. So that minus I am writing here, minus j omega mu naught by h square into c is just a constant, and cos of n pi by b into y is just a constant because that differentiation is with respect to x. E power j omega t minus gamma z is also a constant. But this cos of m pi by a into x, you have to differentiate that with respect to x. So you will get minus that I have written here, and sine of m pi by a into x into m pi by a. This is what is the expression for Ey. So minus j omega mu naught by h square into c into m pi by a into sine of m pi by a into x into cos of n pi by b into y into e power j omega t into e power minus gamma z. That is Ey. Next, I'll be coming to hx, which is minus gamma by h square dou hz by dou x. That means here you have to differentiate again with respect to x. This will be anyway 0 because Ez is 0. That means minus gamma by h square into dou by dou x of this hz expression. You have to differentiate that with respect to x. So what you will be getting is minus gamma by h square will become plus here because minus into minus will be plus, c is as it is, and cos of m pi by a into x will be differentiated with respect to x. So you will get minus sine m pi by a into x, that minus into minus will be plus here, and cos of n pi by b into y into e power j omega t into e power minus gamma z. So that will be your expression for hx. And finally, you need to find out hy, which is minus gamma by h square dou hz by dou y minus j omega epsilon naught by h square into dou ez by dou x. Once again, this term will become 0 because ez is 0 for transverse electric mode of analysis, minus gamma by h square into dou hz by dou y. So that minus here will become plus because differentiation of cos will be minus sign, and cos of m pi by a into x will be as it is. It's a constant because differentiation is with respect to y. That cos of n pi by b into y will become minus sine of n pi by b into y. That minus into minus will be plus here into e power j omega t into e power minus gamma z. So that's it. So this is the expression for hy. So once we get all these four components along with hz, it will be 5. So I'll be showing all the 5 here. So this is hz, which is in terms of purely cos and cos, and this is ex, this is cos and sine, ey, which is sine and cos, hx, which is sine and cos, hy, which is cos and sine. So once we get this 5 equations and other one Ez is 0, so we need to substitute the values of that particular mode. Suppose if it is T is 0 0, here m is 0, here n is 0. Okay, so what will be this hz expression that you have to write up? And similarly for ex also we need to just put m equal to 0 and n equal to 0, and we need to check. Okay, so that's what we have to do once we complete the expression for cutoff frequency for the rectangular waveguide. The cutoff frequency is expression is not separate for both the analysis, that is TE and TM mode of analysis. It is a common expression which we will use it for finding out the cutoff frequency for both TE and TM mode of analysis. So once we get that, we need to check which mode will be existing by defining dominant modes and degenerative modes. Okay, thank you very much. If you like these videos, please subscribe my channel, and my channel is SVS Online Edu Training. Okay, as I told you before, I'll be completely giving you all the videos of this microwave engineering, both in engineering level and gate. This will be have a weightage of around 2 marks, and for the engineering services this will have a lot of weightage, and all other competitive exams. Okay, I'll also try to discuss the problems in this. Okay, along with this microwave engineering, I would also try to make videos of antennas, that is antenna and wave propagation, as well the electromagnetics. Thank you.